Hello everyone, welcome to the course on measurement and instrumentation, and we are in the second week and we are discussing about the analog meters in this particular week. Okay, this is basically the second module where we will mostly talk about the analog meters. This discussion of our analog meters will continue over a few more weeks. Okay, so this is the first lecture of this second week. Let us start with basic definition of an analog meter, or if you are not from the electrical background, you might not have heard this word analog or digital etc. But if you happen from the same arena, if you have done some basic electronic or basic electrical engineering course, you must be aware about the analog signals and digital signals, and the name this analog meter takes exactly from that particular concept. Okay. So, an analog meter basically is an instrument whose output or display is a continuous function of time. Okay. So, the output, say if it is in the form of say current, for example, okay, will be continuous in the time domain. Okay. And this relationship between the input and the time, basically the output maintains a constant relationship with its input. Okay. And when I say constant relationship, it does not naturally mean a linear relationship. Okay. It may be linear, it may be non-linear, whatever. Okay. But there will be a constant relationship with its input, right. So, what I mean to say that say these are the analog meters. For example, say this is the scale which will be deflected. Say this is a M meter, this reads A. Okay. So, which is coming from say M meter or say ampere, okay, whatever you think, and this is deflecting on this scale. Okay. Now, this deflection of this particular pointer, okay, will maintain a constant relationship with the input value. All right. So, the deflection may be varying in proportional to say I, it may be proportional to I square. So, it does not has to be always in proportional with the current I. Okay. It can be proportional to I square, or it can have any other relationship, okay, depending on what tool we are discussing. Fine. So, the analog electrical quantity is basically directly proportional to the torque on moving system. Okay. So, we will discuss about different torques in this moving system of this analog meters world. Okay. And when this analog electrical quantity is directly proportional to torque on the moving system, in turn the pointer movement is proportional to the input, as we have just seen. Okay. So, basically the deflection in these analog meters, I mean in general I am talking about, we will see specifically what happened to particular analog meter, but in general the deflection is directly proportional to the measured quantity. And when I say the deflection, I mean to say the deflection of this pointer. Okay, fine. So, an electric signal, for example current, generates a magnetic or electromagnetic or thermal effect, and in turn it produces a deflecting torque, say I am calling it Td. Okay. What I mean to say that say I have a arrangement of say two coils. Okay. For example, say I have a arrangement of two coils, okay, like fine. Okay. If I pass a current through it, okay, there will be a magnetic line of force extending to this coil. Okay. Or if I am not talking about this magnetic field, okay, if say for example I do not have any coil, okay, I have only say a resistor, okay, and I am passing say a current through it. When I pass this current through it, there will be certain heat generated, or this is what I am talking about, the thermal effect. Okay. And because of these effects, there will be a torque produced, okay, and this torque I am calling as a deflecting torque or Td. We will discuss these concept later on when we talk about the specific analog meter, but for the time being you try to visualize these conditions. Okay, the electrical signal generates a magnetic or thermal effect, or any other say it can be simply electromagnetic effect. Okay, so this effect produces a deflecting torque, and I am calling this deflecting torque as Td. Okay, so because of this deflecting torque, this pointer will keep on moving on this scale. Okay, or it is rotating along this scale. Okay. Now, if I keep on increasing this current, for example, say the field lines will be increasing or the heat will be increasing. Okay. So, this meter will actually surpass this scale, okay, which we do not want. Okay. So, to balance that, what we bring is another concept, which is a concept of a spring, okay, which basically provide a controlling torque Tc. Okay. So, now we are aware about two different torques. One is controlling torque, and which is being provided by the spring. Okay, and spring is somehow attached somewhere here. Okay, and it will see where the spring is exactly attached. Okay, for specific meter. Okay, but for the time being, this spring will try to balance or control this deflecting torque. Okay, and there will be a time when this controlling torque, okay, will be equal to the deflecting torque. Okay, and this state is known as the equilibrium state. All right. So, we will reach this equilibrium state when controlling torque is equal to the deflecting torque. Now, there is a need of a damping torque also. So, a damping torque ensure steady non-oscillatory the pointer motion. Okay. So, to avoid any kind of oscillation that you might have seen in vehicle also, we provide some damper. Okay. So, a damping torque is also required to ensure steady non-oscillatory pointer motion, otherwise it will keep on oscillating along a particular point. Okay. So, we will see the concept of damping torque also in this, but this is in general requirement for a particular analog meter. Fine. There are multiple components that are required for analog meters. Say, I hope that by the discussion that we had till now, you must have visualized how an analog meter looks like and what are its requirement. Okay. So, I will just overview the requirement of an analog meter. Okay. So, first and foremost thing is the pointer. Okay. So, there will be definitely a pointer if you talk in any analog meter, irrespective of it is AC meter or it is DC meter. Okay. So, I will have a pointer in an analog meter. Okay. Then I will have a scale which will be marked in the electrical units. It can be say current, or in terms of I mean, when I say current means in terms of say ampere. Okay, it will be in volts if it is a voltmeter, or it is a ohm meter, it will be in terms of say ohm. Okay. I will also have a spindle which will support the pointer and allow its rotation. So, this will be something like this, and this pointer will be attached here, so that the movement is possible. Okay. Then we will require a spring which will provide the controlling torque. Okay. Then depending on which kind of our system is, we will have a moving coil or moving iron. Okay. So, we will see there are instruments which will require moving coil. We will also see that there are certain instruments which will require moving iron, and all these will be producing the deflecting torque. Okay. Then damping mechanism is required. So, to avoid any kind of oscillation. So, we will see that some of the instrument in some of analog meters, air can provide the damping, okay, while for some we have certain mechanism where the eddy currents are produced in conductors and it provide damping, or in some cases it can also be provided by some other external fluids. Okay. We may see that there are cases where you need permanent magnets. There are requirement of cores. Okay. So, when I say core, I mean to say that kind of cylindrical say non-magnetic conductors mostly, but it can be something else also, mostly cylindrical non-magnetic conductors. All right. Then of course, you have a case or cover which provide mechanical protection, which gives the mechanical protection, but along with that it can also, like spring can also be attached to it, or there can be some subsystem in this analog meter which has to be attached to this case. Okay. So, whenever you try to open this analog meters, you will always break it because some of its part is attached to the case, or it can even house the electronics. Okay. Fine. So, this is the in general the basic requirement or the essential components of a analog meter. Okay. If I am using this analog meters for our day to day task, okay, what advantages it provides over the other kind of tools. Okay. So, the important advantage of this analog meter is they are easier to monitor any kind of fluctuation on the scale. Okay. You can easily see the pointer's deflection and read the even a layman person can read the values. Okay. You do not need any expertise to read that. Say if voltmeter, say for example, say it is showing say this is 10 volt and the needle says that okay, it's 10 volt, anyone can say that it's 10 volt. Okay. You do not need any kind of interpretation for this. Okay. Mostly they do not require any external power, so you can simply connect it depending on what kind of tool it is and get the values. Okay. They are very much cost effective because the requirement is very basic. So, you do not need any external IC and other costly things to operate them. So, they are cost effective. Okay. They also have instantaneous response. So, whatever you want to measure, you just connect and you will get the reading. Okay. And they are less susceptible to noise because you are using very less electronic component here, or null, you are using basically no electronic component. Okay. But then it also comes with different disadvantages, and that is why people has also started looking for other kind of meters, say like digital meters and so. Okay. Because they have low accuracy if you compare it with the digital meters. Okay. There can be parallax. Parallax is something like, say for example, we have discussed that say if you want to read this value. Okay. Now, if the meter is say here, okay, it will depend that if you are seeing from this side or if you are seeing from this side. Okay. If your line of sight is from here or from the top, okay, you may get different readings. Okay. So, that is the disadvantage of analog meter. Okay. So, sometime it becomes very tricky or difficult to read these values. Okay. And they have kind of limited range. Okay. So, of course, there are technique to increase the limit, we will see that also in this course. Okay. But the basic instrument will have a limited range. Okay. Also, you do not have data storage system here. So, whatever output you are getting is the instantaneous value. So, if you want to recall the readings later on, you have to depend on that if you have recorded that reading manually or not. Okay. Then they will require of course calibration against standards. Okay. So, application of this analog meters is tremendous, starting from say testing and troubleshooting in some industry or for against certain equipments. Okay. Then in the automotive diagnostics, in the power supply and motor control, measurement of electrical quantities. We know that across any electrical, electronic, mechanical or any other laboratory if you go, you will find that a lot of these analog meters are kept just to have measurement of electrical quantities. Okay. They are required very much for industrial automation. Of course, laboratory and instrumentation, it is definitely there, and they are also a day to day partner for us, because we all have energy meters installed at our houses. Okay. All are mostly this analog meters. Okay. Then they are also utilized for the power consumption monitor and so on. Okay. So depending on what it reads, okay, it find its application around several utility, like even in our day to day, or be it industry, everywhere they are required. Okay. So I hope that you had feel of what these analog meters are and what are their advantages and disadvantages, and what are the essential components of this analog meter. Okay. Let us try to understand the classification of analog meters, how they can be classified. I mean, there are n number of ways in which they can be classified. We are trying to cover at least 6 or 7 out of that. Okay. So if I want to classify the analog meters, say based on what quantity it is measuring, it can be divided into several types, like you can have ammeter, you can have voltmeters, watt meters, say power factor meters, you can also have frequency meters, galvanometer, ohm meter, phase meter, energy meters, and so on. Okay. Now, based on the function of these analog meters, you can classify them under 3 different heads, including the indicating analog instruments, the recording analog meters, and integrating analog meters. We will see them one by one. Okay. Now, they can also be classified based on the method used for comparing the measured value. Okay. You can have either direct measuring instruments, or you can also have a comparison analog instruments. Okay. Now, based on the principle of operation, you can have different types of analog meters, including moving coil analog meter. You can also have moving iron or MI instruments. Okay. You can also have electrodynamometers or electrodynamic type of analog meters. Okay. Then certain AC instruments like induction type analog meters are also available. Okay. You can have analog meters based on electrostatic forces. Okay. So you have electrostatic type analog meters. Similarly, you have thermal type, Hall effect type, as well as chemical type analog meters. Okay. Now, these are all based on the principle of operation. Now, based on the construction and movement of the pointer, you can have either moving coil or moving iron, or if you are not using such materials, you do not have this kind of arrangement, you can also have a electrodynamometer kind of tool. Okay. And then you have a induction kind of analog meters. So, this is the basic classification based on the construction and movement of the pointer or the coil. Okay. Then based on the nature of signal which it generates or which it can handle, okay, you have either DC instrument or you can have a AC instrument. Along with this DC and AC instrument, you can also have AC DC or universal instrument, which are very important. Particularly these kind of tools can be used for calibrating the AC instrument. Therefore, this kind of instruments are very much required. So based on the nature of signal, you have now 3 different categories of analog meters. You can have DC instruments, you can have AC instruments, you can have AC DC or universal instruments. Fine. So, this is the way in which this analog meters can be classified based on their functionalities, based on their construction, based on the nature of signal, or based on the principle of operation. Okay. Now, as I have mentioned that there are damping techniques which are used to avoid the oscillation. So, based on damping methods also you can have a number of analog meters, like the damping mechanism can be, say, air friction damping. So, you can have tools or analog meters which has air friction damping, you can have instruments which can have fluid friction damping, you can also have instruments which had eddy current damping, and some instrument does not have a damping. So, you have no damping instruments also. Okay. So, some of the example of this damping mechanism based meters are like, say, for air friction damping, mostly this is used in the moving iron meters. Okay. Similarly, fluid friction damping are very popular in this portable instrument, PMMC, dynamometer type of things, and so on. Okay. And then electrostatic voltmeter, which is basically operated at high voltages, so you do not provide any external damping. Okay. So, this is the classification. Now, let us try to understand this classification one by one, so that you have a very solid base on analog meters before we actually go to our discussion on the PMMC and other kind of tools. Okay. So, if I want to classify the analog meters, the first one was based on the quantity it measures. Okay. So, like if I talk about the analog instrument which based on different quantity that they measure, it can be classified as, say, ammeter, voltmeter, wattmeter, etc., that we have just seen. Okay. And all of them measure different quantities which can be of our interest. Okay. Say if I talk about ammeter, it is basically used to measure electric current flowing through a circuit. Some of you might be already aware of this fact, but some of you may not be aware of this. Okay. So, ammeter is basically used to measure electric current which is flowing in a circuit, and it is mostly, say, this is a two terminal device. Okay. And mostly it is connected in series with the circuit, so that the entire current flow through it, and it measures the complete current which is flowing in the circuit. Okay. So, ammeter is always connected in series, okay, with the circuit. All right. Now, the internal resistance of this ammeter is very, very low. Okay. And this has been mostly is kept low, so that it does not any external potential, or say if it is loaded in this resistor, there should not be a subsequent I mean some amount of potential can drop if the resistance of this ammeter is high. Okay. So, usually this resistance of this ammeter is usually kept very low to avoid dropping any voltage across this ammeter. Okay. Representation is very simple, you represent this like this. Okay. So, in this course we will see, as I have mentioned, PMMC tool. So, you will be able to see that PMMC tools can be used as ammeter. Okay. Similarly, moving iron ammeters is also possible. We will also discuss hot wire ammeters in this course. Okay. Then second tool is the voltmeters in this classification, and voltmeter is used to measure the potential difference between 2 points in a electrical circuit. Okay. And it is mostly denoted by V, and mostly it is connected in parallel with the component whose voltage is to be measured. Okay. So, always say for example, if you want to measure the potential drop across this resistor in a circuit, for example. Okay. So, you will connect this voltmeter across the or in parallel with this resistor, say R1. Okay. The internal resistance of this voltmeter is just opposite of ammeter, means it is it has very high resistance. Okay. And this is kept intentionally to ensure negligible current drawing capacity of this voltmeter, or it should not draw any current from the circuit in which it has been connected in parallel. Okay. Usually, as I have mentioned, represented by V, and again you can have PMMC voltmeter, you can have a moving iron voltmeter, and we will also discuss the electrostatic voltmeters in this course. Okay. Similar to the ammeter and voltmeter, we can also have wattmeters, okay, and these wattmeters are used to measure the electrical power in a circuit. Okay. It means that the rate at which electrical energy is consumed or produced can be measured using the wattmeters. Okay. And in this course or in this module particularly, we will discuss the electrodynamic wattmeters and induction wattmeters if the time will permit. Okay. The connection is very simple. It has two coils. So, the current coil or the series coil is connected in series with the load, and the potential coil or the voltage coil is connected in parallel with the load. Okay. So, the internal resistance, if you talk, is very similar to what we have just seen for ammeter and voltmeter. The current coil will have low resistance and the potential coil will have high resistance. Okay. Then we have power factor meters. Okay. So, these power factor meters are used to measure the power factor of a AC circuit. Okay. That is the phase difference between a voltage and current. So, we know that power factor can be given by simply cos phi, where phi is the phase angle between the voltage and the current. Okay. The power factor indicates how effectively electrical power is being converted into useful work, and that is why its measurement is very, very important. So, if power factor is 1, it means that it has purely resistive load, okay, and it is most efficient, while it is, if it is less than 1, it means that there is a presence of inductive or capacitive components, and it makes it less efficient. Okay. In this course, we will also talk about frequency meters. Okay. So, it is used to determine the frequency of an AC or signal, typically which is expressed in say hertz, okay, and it tells how many cycles per second the AC waveform has completed. Okay. So, we will discuss a moving iron frequency meter, or if the time will permit, we will also talk about the reed type meters. Okay. Then ohm meters are again very crucial for our laboratory experiments. Okay. And it is used to measure electrical resistance, particularly in ohms or kilo ohm or mega ohm. Okay. So, it operates by applying a small voltage from an internal battery and measuring the current flow through the resistor under the test. Okay. And this is very much useful in testing resistors, wires and circuit continuity. Okay. And there are multiple ways by which we can read the resistor. Okay. And the resistance also will see different types, low resistance, medium value resistance and high resistance. In this course, we will discuss measurement of all that kind of resistances. Okay. Then we have phase meters. Okay. And these phase meters are used to determine the phase difference between two AC signals. Okay. It means that it measures how much one AC waveform leads or say lag behind the other AC waveform. Okay. And usually this lag is expressed in degree. So, this phase meter will read the degree by which a signal or AC current or voltage is lagging behind or leading any other signal. Okay. So, typically it reads, say if it reads 0 degree phase difference means signals are in phase, and if it reads say 180 degree phase difference means signals are in opposite phase. Okay. And they are used in power factor measurement, phase testing in AC circuit and so on. Okay. Then we have energy meters. This is another kind of analog meter. Okay. This is also known as watt hour meter. So, when I say watt hour meter or energy meter, they are basically same. Okay. It is used to measure the amount of electrical energy consumed by a circuit, device or an entire household in a given time. Okay. So, they measure both the current and the voltage and multiply them to find power and integrate it over time to get energy. Okay. So, mostly we will find induction type energy meters. So, we will try to discuss that kind of devices. Okay. So, it records the basically the total electrical energy used. Typically, its unit is kilowatt hour. So, the energy meters read the values in terms of kilowatt hour. Okay. And they are used in say domestic, commercial, load monitoring and power management, as well as in energy billings. Okay. Galvanometer is another kind of special tool which can be used to measure say very small currents or very small potential differences, and a typical range is for current of few micro amp, while for resistors say a few hundred ohm to a few kilo ohm. Okay. And they are very much useful in bridge circuits, be it Wheatstone bridge or Kelvin bridge, or in the lab experiments. Okay. So, if I summarize these meters, you have ammeter which measure the electrical current and its unit is ampere, and mostly they are connected in series, and application is in the measurement of currents in a circuit. Okay. Similarly, voltmeters measure the electrical potential difference in voltage. Okay. And they are connected in parallel. Okay. Similarly, watt meters can read the electrical power represented in watt. Okay. And they have series parallel connections. The series one is in the for the current coil, while for potential coil it is parallel. Okay. Similarly, power factor meter, it gives your cos phi value, it is a unitless value and connected in parallel mostly. Okay. Then frequency meters read the frequency in hertz and again connected in parallel. Okay. The galvanometer which can read the small current, okay, in ampere and mostly connected in series and useful in bridge circuits for null detection. Okay. Ohm meter reads electrical resistance in ohm. Okay. And mostly in connected in series. Okay. And have their own battery system. Okay. Then phase meters measure the phase angle between two AC signal represented in degree. And is connected mostly in parallel. So, it will read the phase lag or lead between two AC signals. Okay. And energy meters again which measure the electrical energy in kilowatt hour, okay, can have series parallel connections. Okay. And are very much useful in the energy consumption in billing, and mostly the industry rely upon it. So, I hope that this kind of classification is clear to you. Okay. In our next class, we will keep on our discussion on analog meters classification, and we will discuss the classification based on the effects used and other ways of classification. Okay. So, once you understand this classification, the understanding the usability and operation of these meters or analog meters will not be that difficult. Thank you.